Welcome to Ms. Smith's Math Tutorials. This is Ms. Smith. In this video, we're going to be talking about systems of equations using the substitution method. So in the last video, we looked at the same type of problem, only solving it through graphing. In this video, we're going to solve through substitution. So this is taking a more algebraic method of solving these problems. So you'll notice in this first example, we've got two equations, and I know in the last video, the first step was make sure your equations are in slope-intercept form. That's actually not necessary when you're doing substitution. So you would want to do substitution when you see that you have got either an x or a y very clearly alone in one of your equations, or close to being alone. So that you could easily get it alone. That would be when you would want to use substitution. So let's talk about this word substitution for a minute. If you're going to substitute something in, for example, on days when I can't go to work, I would have a substitute, which would be somebody who would come in and take my place for the day. They would sub in for me. So we're going to use that same concept here of substituting in numbers for variables to solve this equation. So what you see in number one, this would be a perfect ideal problem where you would want to use substitution because I already have x alone and I know what x equals. So remember in my last video we talked about how our answer would always be in an xy form, right? Because we're looking for the intersection of these two linear equations. Okay, so what's nice here is I already know what my x is because it's told me x equals 5. So I can go ahead and fill in my x. It's 5. So now I'm halfway to my answer. I just need to know what my y is. In order to find my y, if I know that x equals 5, can't I take that 5 and substitute it in for that x? So let's rewrite that bottom equation, substituting in 5 for x. So you'll notice what I've done, and I've used a different color here just to show you and demonstrate the point. You, of course, do not have to use a different color. But I'm just showing you that I have plugged in that 5 for the x. So I have completely replaced the x with the 5. A lot of students try to just put the 5 with the x. So then they would write 2 times 5x. But no, the 5 is completely subbing in for x. It's totally covering it. So now at this point, looking at what we have, I just have one variable that I can easily solve for. So in that first equation, I had 2 variables. There's no way I can get a perfect answer. But now I only have one variable. So it's pretty easy to solve. I just need to simplify. So 2 times 5 would be 10. Bring down my plus y equals 10. My goal is to get y alone so I can figure out what it is. So I need to subtract 10 from both sides, and interestingly enough, 10 minus 10 is 0. So that's okay. That means y is 0. So there's the other part of my answer. Y is 0. So once I get both my x and y component, I'm good to go. I've found my intersecting point, and I've solved this system of equations. So let's look at number 2. So in this case, I'm not able to go ahead and fill in my answer. I can go ahead and write up here the spot where my answer is going to go, my x and y point, but over here it was nice because my x equaled 5, so I could go ahead and write that in. Here, y equals 2x. I can't go ahead and put 2x in for y. I have to have a set whole number. So I don't get that nice shortcut here. That's okay. It's just going to take me a little longer to solve it. So again, this would be a perfect time to use substitution because you'll notice I already have one variable alone. So in this case, I had the x alone, and in this case, I've already got the y alone. So this is a perfect substitution situation. So if I know that y equals 2x, then can't I go ahead and substitute in my 2x for y, because I know y is equal to 2x. So can I put 2x in for y? Yeah, I can. So I'm going to rewrite this bottom equation. Okay, so again, you'll notice I just kind of highlighted in blue the fact that I'm completely putting in 2x for y. I'm substituting it in. So now, again, it's just a basic algebra problem that I need to solve. Well, here I've got this -2 times 2x. I need to take care of that. It's kind of like distributing this 2 into that 2x. So let me rewrite what I've got. 5x, -2 times -2, positive 2x would be -4x equals 3. I need to combine my like terms here, so 5x minus 4x would give me just x equals 3. Okay, well there's part of my answer, so I know what x is now. It's 3. I still need to know what y is, so that's only half my answer. So what I'm going to use is substitution again. So now that I know x is 3, I can come back to either of these two original equations and plug in 3 for x, and I can solve for my y. So I can either plug in 3 here and solve this equation, or I can plug in 3 here and solve this equation. Now looking at this, I definitely think it's going to be easier to solve that top one. I've already got my y alone, so you're welcome to do the bottom equation, but it's going to take you a little more work. So essentially what I'm doing is I'm taking this x equals 3 and I'm plugging it in right there for x. So let me rewrite that equation subbing in my 3. So you'll notice I highlighted in blue the fact that I'm subbing in 3 for x. So it was y equals 2 times x. Now we see y equals 2 times 3. So let me go ahead and simplify this. Y equals 2 times 3 is 6. So there's my y. My y equals 6. So there's part 2 of my answer. So I know that these two lines have an intersecting point of 3 and 6. Sorry, I said that wrong. An intersecting point of 3, 6. Let's look at another example of this. Now, you'll notice I have left the whole page open to do this problem. This is honestly, substitution is not going to be the best way to solve this problem. The best way to solve this problem would be using elimination, which we're going to talk about in my next video. However, it's a little strange, but you are going to have times on your tests or quizzes or homework where they're going to give you a setup like this, and they're going to ask you to solve it through substitution. Even though it's not the best way, you need to know how to do it. So let's solve it. You'll notice that in both of these equations, I don't really have an x or a y alone, or even really close to being alone. So I'm going to have to do some work just to get an x or y alone. So there's no wrong choice here. I could try to eliminate that x, that y, that x, that y. It doesn't matter. It's just whatever you pick. I'm going to go with trying to get this y alone. I just see that there's a -1 there as opposed to dealing with other numbers. That's just what I'm going to go with here. There's really no wrong choice. You should get the same answer no matter what. Okay, so I want to get this y alone. I'm going to rewrite this equation right here. -x plus 2y equals 4. All right, so I'm going to start by adding this x to both sides. Bring down my 2y equals, I can't combine those two, but I can rewrite them in standard form. My last step to get y alone would be to divide everything by 2. So I would end up with y equals, this is a 1x divided by 2. I can't reduce that, so it's just going to be 1/2 x. And positive 4 divided by 2 would give me positive 2. Okay, so now I have an equation where I just kind of moved some furniture around with this top equation so that I had a variable alone. Now I have my y alone. What I'm going to do is, if I know y equals 1/2 x plus 2, I can take 1/2 x plus 2 and sub it into the other equation, so this one down here, in for y. So that's exactly what I'm going to do. Okay. All right, so you'll notice what I've done is I've literally just subbed in this in blue. I've highlighted it in blue in for the y. So now I've got an algebra problem I need to solve. So you'll notice I only have one variable in this problem now, only x. So that's what I'm going to be solving for, trying to figure out what is my x. So we know the first step of solving is get rid of any parentheses that you might have. So I'm going to need to distribute this -3 throughout that whole parenthesis set. So I get 5x. -3 times 1/2 is going to be -3 over 2x. And -3 times positive 2 is going to give me -6 equals 1. All right, so I've got some like terms that I need to combine here. Okay, so 5x minus 3 over 2x is going to give me 7 over 2x. Bring down my -6 equals 1. My goal is to get x alone, so I'm going to add 6 to both sides. And I get 7 over 2x equals 7. My last step to get x alone is going to be to, and there's a couple ways you could go about this when this is a fraction, but I'm going to go about this just by saying that I've got 7 divided by 2 times x, so I can divide out that 7 divided by 2. I know it feels weird dividing by a fraction, but you can do that. So those would cross out. 7 divided by 7 over 2 actually is going to give me a whole number. It's going to be x equals 2. So there's part of my answer. I'm going to come up here for my xy answer, and my x is 2. Took me some work to get there, but I finally found it. X is 2. So I now need to know my y. So what I can do is take that x and substitute it back in. I can pick this equation or this equation. There's no wrong choice, it's just whichever one you want to do. So I'm going to, I think I'm going to plug it in right there for that x. So you could do that one. I'm just for no really reason other than I'm choosing that one. So I'm going to take this x equals 2. I'm going to plug it in right there. So let me rewrite that over here. Okay, so you notice I'm highlighting in blue that what I'm doing is subbing that 2 back in for the x. So now I'm just going to simplify and solve for y. So 5 times 2 is 10 minus 3y equals 1. I'm going to subtract 10 from both sides. So I get -3y equals 1 minus 10 is -9. And my last step to get y alone is to divide out that -3. Divide out that -3. And I get y equals -9 divided by -3 is +3. So there's part 2 of my answer. I found my y. It is 3. So I had to do a lot of work on that one. Again, you'll find out in my next video, we could have kind of taken a shortcut on that one, but don't worry about that right now. The point is being able to solve any equation given to you using substitution. So that's how you would do it. Let's look at some more examples. If you recall on my last video where we talked about graphing, my last two examples that I showed you were kind of special cases that you'll see. These two are also special cases, so I wanted to make sure to show you examples like these so you would know and you've seen every possible type of situation for substitution that you could see. For number 4, again, it's not an ideal situation for substitution simply because I don't have an x or y alone, but we've got to know how to do it. So I want to get either my x alone here, my y alone here, x alone there, y alone there, whichever one you choose. There's really no wrong solution. So I'm going to choose, because this y is already positive and already alone, I'm going to target that y and get that y alone. So I'm going to rewrite that top equation, 2x plus y equals 7. And I'm going to subtract my 2x, So I get y equals, you'll notice I can't combine these two, but I can rewrite them in standard form, keeping their signs the same, so keeping that 2x negative and keeping that 7 positive. Okay, so now I've got something where my y is alone. So I can take this, if y equals negative 2x plus 7, I can plug that into my other equation for y. So I'm going to plug it in right there. So let's rewrite that bottom equation. Okay, so I've just taken what I know y equals and substituted it in here for y. So you have to be really careful with this one because that's a negative y, so it's a -1 out front of the parentheses on top of the 2 being negative. That's going to be a double negative there. Just be cautious of that. As we know, I want to solve for x now, but first I got to get rid of those parentheses. So that's an understood -1 in front of the parentheses that I need to distribute in. So I'll end up with -2x plus -1 times -2x is plus 2x. -1 times 7 would be -7 equals 6. Okay, I've got some like terms over on this side that I can go ahead and combine. So -2x plus 2x. Those cancel out because that's 0. Let's see what we've got left. Bring down my -7 equals 6. All right, so now you've got to ask yourself a question. Does -7 equal 6? Is that a true statement? And the answer is no. That's a false statement. So therefore, these two systems of equations have no solution. Remember, you can write out no solution or you can just write NS, whatever works for you, but there's no solution that would work for this equation and also for the second equation. So that's one example you'll see. If I were to graph these two lines, like we kind of referring back to that first video where we talked about graphing, if I were to graph these, which I could, these two would be parallel lines. They would not intersect at any point, so it would be no solution. Number 5, this is our second type of special case. So luckily here, hopefully you'll notice that my y is alone. That's what I want to look for an ideal substitution situation. So if I know y equals 4x minus 11, I can go ahead and sub that in for y in my other equation. Okay, so I've highlighted in blue what I've substituted in, completely replacing the y. That -1, understood 1, is still hanging out front of the parentheses. So that's going to be my first step. Always in solving is get rid of any parentheses. So 4x, -1 times 4x is -4x. -1 times -11 is positive 11 equals 11. I want to combine any like terms, so I've got 4x minus 4x. Again, those cancel to 0. Let's bring down what I have left. 11 equals 11. So again, we're in a situation where I say, do we have a true statement? In this case, 11 does equal 11. That is a true statement. So for here, we would have infinite solutions. So that means if we were to graph these two lines, they would be the exact same line. So there would be an infinite number of solutions that would work for both of those equations. So in my next video, we're going to be talking about using elimination. And as I pointed out in this video, it might be kind of fun for you to watch the elimination video and come back and look at some of these examples, like number 4, that would be, and definitely number 3, that would be better solved through elimination. So that might be kind of a test for you to watch the next video and then come back and try to solve these using elimination and see if you get the same answer. But this has been Ms. Smith's Math Tutorials.